Here is question number 7 on trigonometric ratios and angles. Find the measure of principal angle if it lies in quadrant 3 and its related acute angle is 25 degrees. State all coterminal angles to this principal angle in the interval minus 720 degrees to 720 degrees plus. Okay, so there are two parts to this question. So the first one is we need to find the measure of principal angle if it lies in quadrant 3. So let's sketch one. So this is our quadrant, making slightly bigger here so that the things are very clear. It's quadrant 3. So terminal arm is in quadrant 3. So that is our terminal arm and it makes an angle of 25 degrees acute angle, right? So that is the 25 degrees acute angle. That much we have. So this is given to us. Now what do we need to find here? So it says find measure of principal angle. Now principal angle is the angle. What is principal angle? Principal angle is the angle which is always measured from positive x-axis to the terminal arm in the direction counterclockwise. So that is the principal angle, correct? So that is our angle theta p. Now how much is theta p? That we can find by adding 180 degrees to 25. That is how it is, right? 180 plus 25. So we say principal angle theta p is equals to 180 degrees plus 25, correct? So that gives us 5 and 8 and 2 is 10, so 205 degrees. So that is the principal angle. Now that's part 1 of the question. Part 2 is state all the coterminal angles to this principal angle in the interval minus 720 to plus 720. That means two more circles, correct? If we go one circle, then it is, so basically it's something like this, that we go through these circles. So if you do one full circle, that is 360 degrees, right? Then you do another circle, 720 degrees. So more than 720 degrees or less than 7. So that is within this, right? So between these two circles. Now, so that means if you go from the positive side, then the first value will be the principal angle 205 itself, right? So first value will be 205. So first answer is 205 for us. Now to find the next value, what we need to do is we need to add 360, correct? 205 plus 360. So if you do that, you get 5, 6 and 565. This is within this. So we get second answer as 565 degrees, right? Now if you add 360, it will go beyond. So that is not permitted. 800 is beyond this, correct? So we are not just those values. But the other values could be that you could go in counterclockwise direction, correct? So that is to say, coterminal is you can go in either direction. So if you go from here to here, then how much it is, correct? So that means 205, so we take away 360 degrees. So whenever you're measuring from here, it is negative. Is that okay? So we'll do 205 minus 360 this time. So when you do 205 minus 360 degrees, what do you get? So we'll now take away 360 from here. So we'll do with calculator 205 minus 360 degrees, we get minus 155. So let me write down here the negative sides. So that means we are doing 205 degrees minus 360. So when we do that, we get minus 155. So these are the other values. So we can get minus 155, that is one combination. And then we can do further minus 155. Minus 360 again, right? So we repeat this process. So we get 5, 6 and 1, 11 and 5, 1, 5. So we get the other value as minus, this is also minus 515, right? If you further do minus 360, you go beyond the range. Do you see that? So that is not permitted. So these are all, so the part 2 is coterminal. So let's call them theta c. So we got 4 values. So these are the 4 values for coterminal angles, correct? So that is how we can get our values. So coterminal angles you get by, let's say, theta principal angle plus minus n times 360 degrees. That is how you get the coterminal angles. Now since we are given a domain that is between minus 720 to plus 720, we got these different values. So now we can write down our answer. So the answer in this case is that the principal angle theta p is equals to 205 degrees and coterminal angles are minus 515 degrees, minus 155 degrees, 205 degrees and 565 degrees, right? So these are all the possible answers for the coterminal angle. Okay, that's how we'll solve this. Thank you.